Mr. Catlin here, guys, with your homework help. Lesson 5, let's jump right in. What is the same about these two experiments and what is different? Well, if you look at them, they're both randomly selecting a letter from these two words, Alabama and lamb. Something that I noticed that is very similar as I look at them is their sample space. So something that is the same. I would say is their sample space, because the sample space for Alabama is A, L, A, B, and the sample space for lamb is L, A, M, B. Oh, no, not an A. Don't need it happen twice. There's an M in there in Bama. So each of them have the same 4 letters. So the sample space is the same. But something that's different about them is your probabilities of getting the letters. So something that's different would be probability that I get an A. In the first one, the probability is 1, 2, 3, 4 out of 1, 2, 3, 4, 5, 6, 7. So probability of getting A from Alabama is 4 out of 7, where in lamb it's only 1 out of 4. So the probabilities of getting A are different. You could also say the number of outcomes is different, right? One of them has 4 outcomes. The other one has 7 there. So a big difference there. All right, let's look at number 2. Andre picks a block out of a bag of 60 times and notes that 43 of them were green. What should Andre estimate for the probability of picking out a green block from the bag? Well, that's easy. 43 times out of 60. And that's his estimation. May looks in the bag. She sees that there's 6 blocks in the bag. So that means that technically the probability of getting something is out of 6. Should Andre change his estimate based on this information? Well, lucky for Andre, 60 is very nice with 6 because it's a multiple, right? It's just 10 times bigger. So whatever the probability of getting green could be multiplied by 4 and get what we're looking for. Now, in his example, he had 43. So if you divided by 10 and went back, you would get 4.3. So I would change my estimation here. I would go from saying 43 out of 60 to just being 4 out of 6. I would almost guarantee, looking at these results, that I bet 4 of those blocks, of those 6 blocks, are green. So I would change it to, yes, change to 4 out of 6, or 2/3, because it just seems like that's what's happening there. 43 out of 60 is not going to come out an out of 6 type of relationship, right? So 2/3 is what I would go with there. Number 3, a person suspects a standard number cube is not so standard. They have some suspicions about this number cube they've been rolling, because when they roll it 100 times, it lands on 640. They do it another 100 times, it lands on it 42 times, and they do it a third time. This person has way too much rolling time on their hands. That's 300 rolls of number cube. Sorry, I've got other things going on in my life. But anyway, this person has got some suspicions about it not being fair. 33 on the third time. You're getting a 6. Based on these results is the evidence to help prove that this cube is not a standard cube. So we're going to look into the evidence here. Well, mathematically, you're supposed to roll on a standard number cube a 6, 1 out of every 6 times. So if I extrapolate that out or expand that out to 100 times, okay, and I divide 100 by 6 and I find my constant of proportionality here. And when I divide 100 by 6, you'll get 16.6 repeating. Trust me on that. Okay, so my constant is 16.6 repeating, which tells me that if I'm going to do this 100 times, I'm expecting to get a 6 about 16 or 17 times. So 16 or 17 is expected for a 6 on 100 rolls. I think that 40, 42, and 33 are suspiciously high. Now, is it impossible? No, you could get that. It could happen. Is it likely? No, maybe happening once, maybe the 33, you crank out 33 sixes in 100 rows. Yeah, that could happen. But for it to happen 3 times in a row, I think we got enough evidence there to prove that that's a weighted dice or die. All right, number 4. Textbook has 428 pages numbered in order, starting at 1, 1, 2, 3, 4, 5, blah, 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 all the way to 428. You flip a random page in the book. Okay, close my eyes, open it up. It's equally likely to land on any of the pages that you stop at. Okay, so everyone is random. Okay, there's no bias to front, back of the book, middle of the book, wherever I'm going. All right, I need to answer these questions, A through C. What is the sample space for this experiment? Well, it's 1, 2, 3, 4, 5. How much time you got? We could keep going all the way to 428. We're not going to do that, okay? I'm not going to make you do that. There's not enough space on this page. All right, it's 1 through 428. That's your sample space. We're going to do that as a range this time, okay? What's the probability that you turn to page 45? Well, a lot of people will write 45 out of 428. That's wrong. 45 is only one of the 428 pages, and that's your odds of actually getting that. It's 1 out of 428. What is the probability that you turn to an even numbered page? Well, in between 1 and 428, it's an even number, so there's the same number of evens as there are odds in that list. So really, you just split that in half. You got 214 out of 428 ways, right? Because half of 428 is 214. So half, you've got a 50% chance of getting an even number and a 50% chance of getting an odd number because they're the same in each. If this ended in 429, there would be a slight favorance. I think I just made up a word. Favorance. There would be a slight favor to the odds because you ended with an odd and you started with an odd number. But we're not going to get into that. This is straight up 50-50. Hope I helped. Bye.